Cool. I have a hard stop in 1 hour.
Yeah, no
Yeah,
worry,
so
no worry,
hopefully
no worry.
we'll record the session. Okay.
Yeah, you can share your screen and take over.
Sure. Let me quickly bring that up. Second.
Hey, Paul Jayan.
Hey.
Hey, Chua.
Hey, Chua, how are you?
Fine here.
Awesome. So let me.
We have Jayan saying AKS today.
Okay.
So let's. So let me see. Okay. Can you guys see my screen?
Yes.
Okay. One thing that I hate about this is this bar never disappears. It takes its own time.
Yeah, that bar sometimes very annoying.
It is. I don't know why it just doesn't go away. And generally, what I do is just unshare and then reshare again. Sometimes it does.
You can try to click it, and then move your mouse away. Sometimes it will disappear.
Really?
Yeah.
Okay, now it disappeared. You see?
Okay.
All right. So should we get cracking?
Just get started.
Okay,
Yeah,
cool.
Okay, thanks.
Hey guys, I'm not sure how many of you have joined so far, but just before we get started with modernizing applications using Azure Kubernetes Service on Azure Stack at CI, I know we should have, kind of put that out saying AKS on Azure Stack at CI. But if you look at the logo of Azure Kubernetes Service, actually, so myself and Co were checking just before the start of this session. So that logo is actually represents AKS on Azure Stack at CI. In fact, AKS in public Azure has a different logo altogether. Okay, there's something to keep in mind. But nevertheless, so this session is going to be AKS on Azure Stack at CI. So before we get started, right? So I'm not sure what is the comfort level in terms of understanding Kubernetes. How comfortable are we with in terms of Kubernetes?
Basic level.
Okay,
Yeah,
so
you treat us like a baby.
okay, so what I've just done, because I'm actually currently doing CKA certification, which is called a Certified Kubernetes Administrator. So I've actually put together as I'm learning through the CKA modules and everything. So I thought it's a good idea to kind of share my learnings across the community as well. So I've started building this GitHub page where I'm kind of documenting all my learnings here. So what I'm going to do is probably share that link. I know this, just keep in mind, this is something that is still under construction. So which means at least the one good thing is it's the fundamentals are covered. So most of the fundamentals I've kind of documented, but there's there's a lab session which I've kind of planning to do. So it's still, I would say, work in progress. So, as you can see, it's just incomplete here. But yeah, over the period of time, you will see more and more pages out here with all the information. Okay. All right. So then we can get cracking. So it's very difficult to have AKS distribution, or for instance any Kubernetes distribution without the picture of this ship, right? This is at least most of the presentation that I've been through kind of have this picture. It's because it's that much more easier to educate people on what Kubernetes is all about, right? Now, so if you look at Kubernetes, I don't want to kind of go into what is Kubernetes, but that's the reason why I shared that GitHub page, so that you can just go and learn yourself for the basics of Kubernetes, which is kind of easier as we kind of learn through the AKS on Kubernetes, AKS on Azure Stack at CI. But nevertheless, I just want to kind of give you a quick heads up on what is Kubernetes, right? So you can think Kubernetes to be something like, compare this to be a ship, where you have a number of containers, sometimes hundreds, and sometimes it can scale up to thousands of containers. And there's one thing that you see here. There's a tower that's in here, like it's kind of something like an orange kind of a tower. What the job of this tower is basically, to kind of orchestrate all these containers within the ship. So it's like you have a control tower, which kind of manages which container needs to go where, which container needs to be embarked, which container needs to be offloaded, which container needs to be loaded into the ship. And you can think of the entire ship as a node, which means a node carrying these containers. Okay, so you can basically scale the number of containers within the node, or you can even scale the number of nodes as well. In this case, probably increase the number of ships, right? So that's the whole purpose of Kubernetes, right? One of the things that you keep in mind is containers are stateless, which means you can just bring up a container and you can just offload a container, just like offloading a container from the ship. So one of the goodness about containers is the density that you can accommodate per physical node, or it could be a virtual node as well, right? As against, let's say, an operating system that you would normally deploy on a physical node, right? The number of containers that you can deploy on a node is significantly much higher compared to, let's say, an operating system that you can potentially deploy, on a physical node, on a physical server as well in this case. So, the thing about containers is that why many industry, everybody is trying to embrace containers, the de facto standard for deploying or developing applications, is because it makes it so seamless. When I say seamless, right, you can package your applications. It could be an application may consist of your databases, your middle tier, or your backend tier like database, your middle tier, which is a business logic, or your front end tier, which is your like a web tier or something like that. All of that in a single container, and this container does not have any dependencies on the underlying platform or the infrastructure. It doesn't have any dependency on the physical hardware, doesn't have a dependency on the operating system where it's deployed onto. As long as you have a common layer for the container orchestration. So in this case, probably something like Docker, like a Docker layer, you can just go and deploy this container anywhere. One of the biggest advantages of why organizations today are embracing or containerizing their traditional way of developing an application is because it reduces so much of overhead, right? Dependencies. So think a classic example that I would generally give is when customers develop applications in a traditional way of developing their application. So generally they develop it in their infrastructure, which is development infrastructure, which may have a particular operating system tied to it, which may have a particular build system tied to it, and eventually they build the application, and then they deploy that application. So now they hand the same application over to, let's say, an operation team, which is probably typically who's in charge of deploying these applications in a production kind of environment. Now, all of a sudden, the production environment has a totally different infrastructure, totally different operating system. Sometimes they're all tested in the development environment, but some variables may not be, right? And suddenly then you have a breakage and saying operations team will come back and say, hey, you know what, this didn't work because it gave me this error. And somebody from development team goes and checks what's happening, and they determine some libraries and some dependencies are missing. And then they go back to the drawing table, rebuild the application, test it for, to make sure that it has the right, dependencies that exist in the production environment, and then they read. So this cycle of testing, redeploying continues until and unless the application is ready to be stood up in a typical production environment. So just think about the amount of time that both people, the development and the operations team, engage themselves just to stand up this application so that it's ready for production, right? So that's the challenge which they have. With containers, it's so much easier because the dependency is significantly reduced because there's no dependency on the underlying infrastructure or the underlying operating system. As long as it's the same Kubernetes layer, which is in this case, it could be Docker. Docker, I'm just giving an example, but there are so many, Kubernetes layers out there. But as long as they have a common interface, for instance, if it's Windows, you have a Windows, container. If it's Linux, you have a Linux container. As long as you keep the fundamentals of the operating system architecture same, you're good. So you can just deploy these containers onto, let's say, if it's a Windows container, you deploy it onto a Windows container host. If it's a Linux container, deploy it onto a Linux container host. It's that simple, right? So there's absolutely no dependency. So most of these, the container hosts are dependent on kernel. When I say Windows and kernel, Windows and Linux, because Windows kernel is different versus Linux kernel. Linux kernel, you may have a different set of applications, different set of Linux distribution, like SUSE or Ubuntu, or Ubuntu or Red Hat, or CentOS, any of these distributions out there. But the only differentiating factor is the kernel is same, which is the Linux kernel. But what you build on top of this kernel, which is the application layer, that's where it starts differentiating between these various distributions. Now, with containers, all you need to do is you don't have to worry about the application part of the operating system, but you only need to depend on the kernel of that particular operating system. In this case, it's Linux, or it could be Windows. So AKS today is perhaps the if I'm not wrong, I think I was reading somewhere in the one of the analysis which was done by RightScale, where they said AKS is the third most popular container distributions out there. So there are a number of container distributions, like for instance, EKS from Amazon, GKE from Google Cloud, AKS, which is Azure Kubernetes Service from Azure. Then you have Red Hat OpenShift. Then you have Rancher. There's so many container distributions out there, but it's very important to understand where did this Kubernetes come into the picture first of all. So Kubernetes was first, kind of was built from ground up in Google Factory, literally. Okay, so Google kind of developed this probably 15 years back, and Google outsourced this to the community, way back in 2014. Okay, so Kubernetes is by far the most popular distributions that is out there. Okay, so now if you so what AKS has done with Azure's Kubernetes service has taken the goodness of Kubernetes, which is available in which most of the industry has adopted already. So they've taken the same Kubernetes.io orchestration, and they've kind of modified this to work seamlessly in Azure and Azure Stack HCI environment. So if you look at the AKS on Azure Stack HCI, it's the same experience that any customers would get today running AKS in public Azure. It's the same exact experience which Microsoft wants customers to have when they're actually consuming AKS on Azure Stack HCI as well. Now, one of the differentiators of AKS, even in public Azure or in AKS on Azure Stack HCI, like I said, it's both the same, is its ability to manage both Linux and Windows-based container applications, right? If you see most of the orchestration tool today, generally they're leveraged heavily on the Linux side because today most applications that are containerized are actually hosted on Linux distributions. Okay, make no mistake about that, right? There are very few Windows-based containers. Now you may question, what are those Windows-based containers? Now I would say typically .NET-based applications, which kind of requires that Windows kernel as the underlying Kubernetes host. So that's where most of the .NET applications are based on Windows containers. But otherwise, that I have seen, most of the container-based applications are based out on Linux platform. And you can scale up or down by adding or removing nodes into the cluster. Same experience that you today have in public Azure. You get the same benefit, even on Azure Stack HCI as well. You can manage the storage and networking on your Kubernetes clusters. So all of this is same. There's no difference. The ones that I've highlighted in yellow that use popular Azure services through Azure Arc, which I'm going to get into, that kind of sets apart AKS on Azure Stack HCI completely different compared to any other Kubernetes distributions out there. Okay, so that is a huge distinguishing factor of AKS on Azure Stack HCI versus any Kubernetes distributions. Now, so Kubernetes, before we talk about AKS on Azure Stack HCI, it's important to understand AKS in public Azure, right? I think that's something that we will start with. So if you look at AKS on Azure today, it has the best in class practices. Now, Microsoft comes with a lot of learnings running AKS at hyperscale. Like I said, AKS today is the third most popular Kubernetes distribution. So AKS is very popular and comes with a ton of experience of running thousands of enterprise-based applications successfully on AKS on Azure. Okay, so now what Microsoft is trying to do is transfer this knowledge to many of their products, like, for instance, AKS on Azure Stack HCI. One of the tenets of AKS in public Azure is multi-layer security. Security is top of mind both in Azure as well as on premises. Now, Microsoft has invested heavily across different layers of the stack, like, for instance, compute, storage, network. This is to ensure every layer is heavily isolated, and a lot of those learnings and technology is now made available on Azure Stack HCI as well. Okay, now Microsoft has a very, very well-established support ecosystem. In fact, I was on a call with one of the Microsoft support specialists where we were actually troubleshooting an issue on AKS and Azure Stack HCI. And to my surprise, when I spoke to the support technicians, they said these technicians are actually coming from Azure. Okay, so just imagine the kind of it's so much seamless to kind of deploy the same AKS expertise, but to handle AKS on Azure Stack HCI as well, right? There's not much of a difference, troubleshooting in AKS on public Azure versus HCI. And the unified management, this is an important part. This plays a significant part in the overall benefit of AKS on Azure Stack HCI, and you combine that with Azure. Now, because customers today who have already embraced public cloud to run some of their applications, so there is a inherent need for some of these applications to be run on premises, right? Because of regulatory needs and so on and so forth. So while they're doing so, they also want to have a disparate experience while managing governance and all of that. Now, using technologies such as Azure Arc, which I'm going to talk about in the next few slides, gives them that unified experience of a single pane of glass, the Azure control plane. Okay, so that is the whole gist of making all of this operate from a single pane of glass kind of an experience for customers. So what does it really mean for AKS on Azure Stack HCI, right? So Azure hybrid by design, this is the most important part. And AKS on Azure Stack HCI, like I said, takes a ton of that goodness that is engineered with Azure and brings it to the edge or core data center through Azure Stack HCI. Now, in a way, it's easier to consume and deploy, which we're going to show in the demo as well. It's also consistent with what industry is doing. Like I said, it's Microsoft has taken the open source tooling that's available with Kubernetes using Kubernetes.io, and they've taken that the same thing. And as industry is evolving in Kubernetes in the outsource community in the Kubernetes, so it is also embracing all the goodness into AKS as well. So it's a constant development of AKS with the industry, in general. So, like I said, .NET applications, it's a great platform, right? It's a fantastic platform for modernizing. There are a lot of customers that I talk to. Many of the customers are still running traditional legacy application on a virtualized platform. So it's a great conversation for us to have, especially when they're thinking about modernizing this .NET application onto Windows containers. It's a natural fit. So security, like I discussed in the previous slides, right? All of this is built in with security at the center, such as the ability to use Azure AD for identity, access management. Make sure containers are up to date. You can also integrate with Key Vault and RBAC and all of that you can think of from a security standpoint. So if you look at the high-level architecture of Azure Stack HCI, right, it's powered by the underlying infrastructure, which is typically the Azure Stack HCI, and it's best powered by the Dell AX nodes, like we've talked about in our previous episodes as well. So that's really what brings the value. Now, the second layer of value is you have a bunch of VMs to power AKS on Azure Stack HCI. So this is where the first layer of value that AKS on Azure Stack HCI provides, this automatic rollout of these necessary VMs to support the applications and the workloads. Now, when I say automatic, it can be a little confusing here because you still need to manage the underlying Kubernetes pods and Kubernetes clusters in general. You're still wholly responsible for managing the underlying infrastructure from an AKS standpoint on Azure Stack HCI, but the value that brings, it's kind of the AKS that brings on Azure Stack HCI is as seamless as AKS in public Azure today. The Kubernetes.io layer, this is an open source code like we talked about from AKS. So anything that Microsoft innovates in Azure brings those values seamlessly to AKS and Azure Stack HCI as well. So all of these layers are packaged inside a service called AKS on Azure Stack HCI. Okay. Now the top layer, which is the Azure Arc control plane, is optional, but I would see it's not as an optional thing, but it's a mandatory thing. But you'll see, when I start doing the demo about how beautifully all this integration really work when you bring Arc into the equation. So, but it feels like for most of the onboarding of other CNCF compliant Kubernetes clusters, Azure Arc is chargeable service. So keep in mind, today customers can not only bring AKS to Azure Arc, but they can also bring any CNCF compliant. CNCF stands for Cloud Native Container Framework. So they can also bring in any CNCF distribution like Rancher or from SUSE or Red Hat OpenShift, for instance, or EKS, for instance. Any of these can be brought into Azure Arc, and you can still modernize your applications using HCI. So it's still applicable today for customers who want to do it. But what is really powerful is when you bring AKS on Azure Stack HCI. Because AKS is natively today available on Azure Stack HCI, it brings in a whole new value for customers, not just from the native availability of AKS on Azure Stack HCI, but also from a cost standpoint, because customers today don't have to pay for like the control plane. They don't have to pay for the orchestration layer. The only thing that they get charged for is a target cluster, which is basically either a Windows container or which hosts the Windows container or the Linux container. Only that they get charged for. All the orchestration part of it is absolutely free. Okay, and including Gitops integration, which I'll show in the next few slides. So this brings us to this important discussion of Azure Arc, right? So now Azure Arc, those of you who are not familiar with, you may be wondering, in a Kubernetes clusters, in a Kubernetes session, why are you talking about Arc? Because Arc is very, very important piece of you would say the value that Azure Stack HCI brings in with Azure, because it's not about customers today. The more and more customers that I talk to today say, hey, you know what? I don't want to have multiple consoles to manage multiple things, right? You are talking about Azure Stack HCI, which has to be managed natively today using Windows Admin Center. Now, I'm already invested in public Azure today using, I'm using public Azure portal to manage all my IT assets, right? Now, I don't want to have multiple consoles to manage my on-premise infrastructure. So this is where the Azure Arc brings those value, which means you can still have a single control plane with this, which is public Azure portal, yet manage all of your on-premise infrastructure. It could be a multi-cloud, it could be a data center with Azure Stack HCI deployed, or it could be in your edge locations, right? All of which can be managed from a single control plane. Now, what Azure Arc in reference to AKS brings in is some of the Arc-enabled services. Okay, so like for instance, think about deploying a data services. For instance, when I talk about data services, it could be a SQL managed instance, or it could be a Postgres managed instance. You can have a same experience of deploying these SQL managed instances or Postgres managed instances in public Azure. The same way you can have this deployed on Azure Stack HCI as well. And the magic that makes that happen is actually happens as Azure Arc. Okay, and then you have Azure enabled infrastructure. For instance, you have something like app services that you can deploy, Azure functions, logic apps, all of that. It kind of starts unveiling a true value when you see, with AKS on Azure Stack HCI, you start seeing a whole lot of Azure services actually being deployed onto Azure Stack HCI clusters. That's the real power of Azure Arc. Combine that with AKS on Azure Stack HCI. So if you look at the architecture of AKS on Azure Stack HCI, right? So you have this management cluster, so which is basically you think about like a resource bridge. It's a mini cluster. It's today running on a single virtual machine, but it's actually has a necessary APIs, the load balancers, the cluster configurations, and basically whose job is to orchestrate the deployment of clusters that will run your customers' applications. So it's a standalone management cluster which is used to orchestrate deployment of your target cluster or workload cluster. This particular one. This is where I talked about the different worker nodes, right? You could have Windows containers or Linux containers, depending on your customer's applications. If your customer's applications traditionally requires a Windows container, which is a Windows kernel, then you deploy your Windows container applications. If it's a Linux kernel-based application, you deploy Linux containers. So this is where AKS on Azure Stack HCI supports both kernels of containers. Okay. And in the center, that's where you have the control plane. So control plane is literally the brain of this overall cluster, right? So this is where the whole orchestration kind of happens. So it knows exactly which applications to go and deploy to which container. Think about, let's say you have a GPU enabled virtual machines. Now you have an application which requires GPUs. So control plane is kind of responsible for, here is a GPU application that needs to go into a GPU based container only. So control plane's responsibility to ensure all of that, including all of the orchestration that you see. For instance, if you see an application that needs to scale up, its responsibility is to kind of scale up the number of pods in that container so that application is able to meet that resource. So all of that orchestration is done by the brain, which is called a control plane. Okay, so as you can see, the underlying infrastructure is still driven by the physical nodes, which is the physical nodes of the cluster with Windows failover clustering in Azure Stack HCI. and each of them will have a cloud agent which kind of talks to the AKS service that you go as you go and deploy. All right, so I know how much time we have. We have 30 minutes. So with that, I think we should get on to the quick demo. Now, deploying Azure Stack HCI, AKS on Azure Stack HCI is absolutely seamless. You have the Windows Admin Center. Within the Windows Admin Center, once you've deployed your AKS HCI clusters, you go into Azure Kubernetes Service that's available here, and then it's completely wizard driven. It does the prerequisite check just to make sure your system, underlying platform, or the subsystem is compatible before you deploy an Azure Kubernetes service. And then it requires you to enable the CRED SSP, and then you're supposed to provide a volume where you can actually store container images, because remember, you need to store either a Windows container image or a Linux container image from the image repository. It could be Azure container registry, or it could be a local private registry as well. So that's where you need that storage to store those container images. And then Azure registration, which is very important. You can skip this as well, but this is very, very important, in my opinion, should be made mandatory, because once it is registered with Azure, you will have that, it'll start unveiling a total new value, which we're going to see in the next few slides on how Azure Kubernetes Service with Azure Arc brings some of the Azure services natively into Azure Stack HCI. Okay, so once you deploy, this is, very simple UI-driven steps. You can just go deploy AKS on Azure Stack HCI, and this is a service. Okay, we're still far away from deploying the cluster, but this takes about 18 to 20 minutes. I know you have deployed this number of times as well. It depends on the resources and stuff like that, but generally I've seen it to take about anywhere between 18 to 30 minutes time you will have cluster up and running. AKS service deployed. Remember, the first step, it's actually a two-step process. The first step is to enable or deploy AKS service. That's what we've just done now. The next step would be to deploy the target cluster, which is nothing but the workload cluster. Okay. So like I said, we're going to be deploying now the target cluster. Again, it's very, very simple, straightforward. So once once the Kubernetes cluster is deployed, you just launch the create Kubernetes cluster. This is where you go and deploy your target cluster. So you can pick the node pools that you want. For instance, you provide all the information that you need for your environment, your Azure Stack HCI, host credentials, and then it's going to validate whether the credentials of that host or host HCI cluster is correct or not. And then the Kubernetes version, in fact, the one that I have right now is 1.22.6. So that's the latest one. And here is where you add a node pool. So node pool is where you're going to be deploying your container applications. It could be a Linux pool. Like I said, it supports both Linux or Windows. So if you have a Windows-based container applications, you want to deploy a Windows container. So in this case, I'm just giving you a demo of deploying a Linux pool, node pool. Okay, so so this is something that I would just pay attention here is when you're deploying a node pool, just make sure that you have adequate resources in terms of CPU and memory, because that's an important parameter. Because remember, this node is the one that is going to host your containers. Okay, so make sure your node pool that you're going to create, either a Windows node pool or a Linux node pool, you need to do something known as sizing. So there's a beautiful Microsoft documentation on how to size your Kubernetes cluster nodes, which is a node pool. So depending on that, you need to do those parameters to make sure that you have enough resources to deploy your containers. Also, for instance, you need to take into account how many containers which I'm going to be deploying, right? And how many such container-based applications which I'm going to be deploying. So all that needs to be factored in before you spin up this underlying node pool. Okay, remember these node pools can be scaled up as well, which I'll show you in the next few when we do the demo. It can be scaled up seamlessly. Okay. All right. So what we're trying to do here is authenticate using Azure Active Directory. So all that can be done is here as well. It needs to have a separate network interface which is attached to the Kubernetes clusters. That's what we are trying to do. We're trying to do here in this demo. And once we have made sure we have provided all the necessary parameters. In fact, I have a step-by-step demo of how to create AKS on Azure Stack HCI on my YouTube channel, which is called Giant on Cloud. So feel free to go check that out. It's a step-by-step procedure as to how I create AKS on Azure Stack HCI. All of that is right up there. But this is just to kind of give you guys an idea about how easier and seamless it is to deploy, to create a Kubernetes a service, and then to go deploy AKS on Azure Stack HCI. Okay, it's as seamless as possible. And then we're going to see how customers will start seeing value, because it's not just about deploying AKS service and then creating a cluster, right? It's about realizing the true value of deploying an application, which obviously can tie into your Gitops, because Gitops is going to be a repository where you're going to be deploying number of applications, right? Because that's where the application binaries would reside. Now, think about if you have to deploy this across thousands of containers, right? Now, Gitops integration becomes that much more important, because you don't want to be going and redeploying every thousands of these containers and say, hey, here is an application binary, go deploy it, right? So you just want to give a single repository a link, and then that would take care of deploying that application seamlessly onto hundreds and thousands of containers. So with that, I think we'll get into the hybrid stack here, right? Now we spoke about how to create an AKS service. We spoke about how to create an AKS node pool, and then we will talk about how you can actually start building this application using Azure Arc and so on. So this is where the Azure hybrid stack comes into the picture. Like I said, with virtual machines, you can deploy on Azure Stack HCI, a Windows VM or a Linux VM. With AKS on Azure Stack HCI, you can not only start modernizing. See, it's a best of both worlds, right? For customers who want to kind of lift and shift their legacy application, which is virtualized applications, they can do that. But customers who want to kind of realize the true value of Azure Stack HCI, which is to modernize their on-premises applications into containers, they can do that with AKS on Azure Stack HCI as well. So as you can see, AKS kind of starts bringing in a new value, like we showed. Like it could be a .NET applications, it could be a Node.js, it could be any Java-based applications. It's not just Windows applications that is supported, right? It supports a whole length and breadth of applications. In fact, AKS workloads, if you see in public Azure, 60% is non-Microsoft. It's only 40% is Microsoft, which is .NET heavy applications. The rest of the applications are all non-Microsoft, like Node.js or Java-based applications. So same goodness, you can bring it to AKS on Azure Stack HCI as well. Okay, so in this demo, I'm going to quickly show you, now that we have deployed AKS service, we've also created a Linux target cluster, which is the Linux node pool. Now we'll see how to deploy application using Gitops. Okay, so as you can see, when you deploy this AKS HCI cluster 01, there's a node pool that I've actually deployed. Now, once you start, so let me get this. Okay, so once you start, this cluster is already onboarded to Azure Arc. You see this here? I'm actually in portal.azure.com, but this Kubernetes cluster is already visible in Azure Arc. And as you can see, it has a number of options that I can say. There are a number of things that I can do. I can add Azure constructs to it. Like for instance, the metrics, the various extensions that are available, the Azure logs, all of that insights, Azure Monitor, integrated into Azure Monitor. And then the most important value is the enable Gitops integration. Okay, so why is there a Gitops integration that is required? Now, think about, let's say you have an organization which has thousands of, think about a retail store. They have thousands of stores spread across in a geographical location, right? Now, what they want to do is they want to deploy an application across these 1,000 stores. Imagine if somebody has to do this manually. If it's a virtualized application, they have to go deploy by hand on each of these stores and make sure the application is running and all of that, right? Just imagine the amount of time it takes. So this is where AKS really comes of a true value, right? So using AKS, let me just pause here. So what we just did here, go back. So what we just did here, we actually created a Gitops configuration. In a Gitops configuration, what happens is I can specify a Gitops repository. What is Gitops repository? Basically, what I do generally, what customers do today, or the industry is doing, is upload the application binaries in the form of either it could be GitHub or Gitops, anywhere. So it's basically a repository URL. Okay, so basically what I'm trying to say here is you can just specify a URL name, the instance name, and where my application binaries are residing, and then I create a config out of that. Okay, so it's a single config, it's a single application, but I want this to be deployed across 1,000 different stores, spread across in a geographical location. Okay, that's exactly what I'm trying to do here. So I created a cluster config which has references to my Gitops repository, and then I would go and deploy this application seamlessly. So as you can see, I have this cluster config instance, so it has a reference to my AKS instance, which is basically the AKS node which I've created here, the node pool. And then the various parameters, like Flux is basically the tool that is used for building the container-based applications in AKS. As you can see, this is the repository URL. So this is where it will go and fetch the application binaries from. Okay. So while we'll wait for it to come out. Okay, so once the configuration is set up, what we're going to show right now, what I'm going to show right now is deploying a sample application, which is a .NET application, and simple, a web application, just to show that this is an Azure or Gitops demo. So as you can see, it shows the pods that are running. So pods are basically inside a container. It's like basically when you deploy an application, it can run into a number of pods as well. So it's also showing me what is a node pool, which is the Linux node pool, which we just deployed. And then you have this Gitops a repository, which is through GitHub. So this is where my application code is residing. And it says there's an Azure or Gitops demo. And what we will do is we're going to change this messaging to something else later. So, and we'll quickly go into PowerShell to see how the container pods are running. So it's very easy to a bunch of kubectl is the way we manage. It's a tool to manage your Kubernetes clusters. So using kubectl get pods namespace, which is hello Azure Arc, I get all the pods that are running. And you see, once I change this, you see how the container pods are automatically changed and distributed the moment I commit the changes. You see the power, right? Now, I don't have to go through, do this across thousands of containers which are deployed, right? Now you see all these container applications are deployed across 1,000 stores, right? And all of this, the moment I change this and commit the changes in my GitHub, it automatically gets picked up using Gitops repository using that cluster configuration. Right? So, oh, sorry. Accidentally close the demo. Okay, so that's really is where the power of the Gitops, and then sorry, I think it's showing from the first. Okay, so there are a number of resources that are available. Before I continue further, so let me pause here. I know we have about 15 minutes. I have a lot of other things to show as well. But are there any questions here before we continue?
Ian,
Yes.
let us you the GitOps, is it?
Yes, GitOps.
Once you configured, how can I actually use it?
So GitOps is something that you use for, let's say, managing your multiple repositories. Okay, so GitOps is again, it's a tool. Like GitOps, there are so many other tools as well, right? Azure DevOps tool is there available and all of that. But so within GitOps, you can manage multiple GitHub repositories or Git repos. So Git repo or GitHub is basically where I will upload my container. I will upload my application binaries. Okay, that's where they reside. And using GitOps, I will pull those repository by referencing them. So to your question, how do I get started? I would say first have a any account in repo. Either it could be GitHub or Git repo. Create an account there. For instance, I have created an account here, right? So you can create repositories. Inside these repositories, you see a number of repositories here, right? So you can have application binaries within these repositories. Okay, and then you tie this repository to GitOps. So GitOps now knows there are multiple locations to pull the application binaries from. It could be within GitHub, or it could be another tool called Git repo. Does it answer your question?
Cool. This is something that I didn't use before.
Yeah. So I'm still learning to use this as well. But Git repo is something that's still new to me, but I'm still getting my hands on with GitHub. So this is where, in fact, you can do a lot of forking. You can bring in your repository from other publicly available repos. So many repos. For example, if I build an application, I may make it available for public. So if somebody, let's say, wants to use that binaries, you can just fork that binary into your, and it'll start showing up in your Git repo. In your repository, and you can customize that repository as you want.
Oh, this is something really good.
Yep. So, and the beauty about GitHub is not only can you bring in application binaries like I'm doing, I'm also building GitHub pages. So cool documentation that you can do, right? It's so powerful. So the best part about GitHub is that you can point to your application repository internally within your GitHub page. So if you want to just go, let's say, deploy an application using your own GitHub repository, you can point that in your GitHub page. So that's the power of getting your documentation and also getting your application binaries in a single place. Okay. Any other questions before? Sorry, this is a different topic altogether, but it's an interesting one. Any other question?
Okay, you can continue.
So as you can see, right, so I have deployed my Azure Stack at CI. There is a workload that is running, which called sorry, not the workload. This is the node pool that I've created. Okay, it's called JY-AKS workload cluster. This is something which is already onboarded. So you see, I've logged into public Azure. Okay, now if I go to Kubernetes clusters, now this is a Kubernetes cluster, which is the management plane, control plane, which I showed you in my demo here. So just go back. There you go. So what it has done is basically this is the control plane. So the VM that you're seeing there is the control VM, and then the node pool, right? So that's exactly what I'm trying to show here. See, this is the control plane cluster, and this is the workload cluster where the Linux pool is deployed. Okay. Now, if I go into this, now you see the power of integrating with Arc, right? So you get all the Azure constructs. Not only that, you can also enable some of the extensions. There are a number of extensions that are available, but I have not enabled them. For example, you can add Azure Monitor, or or application services extension like app services, data controller, which means using Azure Arc Data Controller, I can actually create data services like SQL Managed Instance and so on. Azure Machine Learning. You see the power, right? So as more and more, Microsoft is also adding to build more and more extensions so that you can make use of these extensions to modernize your applications. So and then one other thing that I wanted to show is the power of Azure Arc, right? So with AKS, so you likewise, like AKS, you can also onboard a non-AKS cluster. It does not have to be AKS alone. You can bring in any Kubernetes orchestrated distributions out there. For example, SUSE Rancher, or Red Hat OpenShift, or EKS anywhere. So all of that can be brought in as well. So as you can see, right, it says to identify a Kubernetes cluster, you can add an existing cluster. The cluster must be whatever. This is for AKS. But if you also want to bring in any new Kubernetes clusters, like any CNCF Kubernetes clusters, you can bring that as well. See, it says Red Hat OpenShift. So there are a number of Kubernetes clusters that are supported. In fact, I don't have that somewhere. I think if it is there. So let me Google. Sorry. Okay. I think there are a number of Arc enable, Azure Arc enable, validate partners. You see this? There are so many, just that they need to be CNCF compliant. You have Red Hat OpenShift. You have Tanzu on VMware. You have Charmed Kubernetes, SUSE Rancher, like I said, and Wind River. So many distributions are available, and all of this is validated against these distributions. So like I said, it's just it needs to be a CNCF compliant cluster. And once you onboard that cluster, then you can actually deploy anything. For example, SQL Server, so not SQL Server, SQL Managed Instance. Okay. Now you may be wondering, hey Jen, you're talking about deploying AKS clusters or any CNCF cluster, and then you're talking about data services. Why is that? Right? Because most of the data services or application services like app services and all of that is a containerized applications. So you need a basic Kubernetes orchestration service that's available on Azure Stack HCI. It could be AKS or it could be any other Kubernetes distribution, right? So if you see in this case, right, what I'm going to do is actually basically I can deploy a SQL managed instance, which is a containerized SQL application onto my Kubernetes clusters. Okay, so I can just say AKS HCI and then instance SQL mi1. And so this is where I create a load balancer, and you see the power, right? I can pick my SQL server of my choice, how my SQL server needs to be. I will just say, because I don't want to incur any cost, I will just say deployment purposes only, and say provide the SQL memory extension, and then provide a SQL managed instance username, for example, app admin, something like that, right? And just go deploy. So what happens is it'll go and deploy a SQL containerized application onto my Kubernetes cluster. I'm not going to deploy it right now, but just want to show you how easy it is. Just like SQL managed instance, I can also deploy app services. So for all of that, the basic foundation, even the Azure virtual machine that I create, it actually requires AKS service to be deployed because it's a containerized application. Okay. So like I said, that's the true power of, just to summarize, right? I know we are closing in on the time. Just to summarize, so it's AKS, which is the Azure Kubernetes service, is available in public Azure today. It's the third most popular container distribution out there. The same AKS today is available on Azure Stack HCI as well. So if you see customers today who are trying to modernize their on-premises legacy virtualized applications into containers, it's a great conversation to have, especially on Azure Stack HCI. Now, why should you really care about AKS on Azure Stack HCI? One, AKS brings the same value add that's available in public Azure to on-premises on Azure Stack HCI. Second, it's also, from a cost standpoint, it's that much more cheaper. For example, all the Gitops demo which I did, it's all absolutely free if customers are running it on AKS. But if it's on any other third-party distributions, they will be charged for it, including the control plane cluster, right? They have to pay for the control plane cluster. But in case of AKS, they just have to pay only for the workload cluster, which is the target cluster. Okay, so that's the true value of AKS brings into Azure Stack HCI. So it's a great conversation to have. Like I said, AKS, since AKS supports both containers, that's again a differentiator compared to any other container distributions out there. It supports both Windows containers as well as Linux containers. So it makes our jobs that much more easier to have conversations with customers traditionally who are heavily invested. So there are a ton of .NET heavy customers out there. It's a great conversation for us to have, especially if they're thinking about modernizing. Okay. Any other questions before we call it a day?
Pretty good, Jen.
Cool. Cool. I think we're just 4 of us, I guess. Okay, great. But this session is recorded anyway, right? So I think this can go out too. Okay, awesome.
I will share it to other partners who actually has a exploration on the AKS. And I think this is very useful because you have shared a very good way to actually manage the repository using the GitOps.
Yes, very powerful, especially when you bring in GitOps into the equation. It is a totally different beast altogether. Very powerful. And that's how, that's generally what I tell customers about, right? It's about how you manage, how you automate your stuff, right? So without containerizing your applications, you cannot achieve all of this.
Pretty good. Thanks for sharing, Jane.
My pleasure. Thanks again. Thanks everybody for joining in.
Yeah, keep in touch.
Yep.